If you've got a question, the voices of resin are here. Oh, PlastChicks.
PlastChicks is an SBE sponsored podcast.
Hi,
Hey, girl. How's it
look at
going?
you with your little split shirt, feeling
Yeah, it's like
all sorts of
color
color
stuff
block.
from the
You're really
early
living for the
90s.
color. Well, I mean, we kind of coordinated because I got the lipstick and the shirt kind of matching the top half of your shirt.
Absolutely.
So-
We planned that.
We did plan that, so everyone who is not on the visual feed, we look identical. You can't tell us apart. 100% twins. Okay, so, we got a podcast to record. I think that is the purpose of this adventure here. I'm Lynzie Nebel, and I'm an upstream product quote engineer for Cytiva.
I am Mercedes Landazuri, and I am a color expert, and met Lynzie through some of the work that we've done for and with SPE. And with our powers combined, we are
PlastChicks.
the voices of resin.
We're so good. So our podcast comes out the first Friday of every month. So you can listen to us anywhere that a podcast shows up. And then if you're feeling extra fancy, you can check us out on YouTube for the visual, so you can actually see how much Mercedes and I are twins. Or you could just, watch the awkwardness along with the audio. That's exciting. And we're on social media, all the social medias.
Not TikTok yet.
Except for TikTok, but we have the handle. We will probably never make a TikTok, but
we'll talk about it at least.
We will talk about it until TikTok gets taken down by the government. Okay. And today we have a guest that I have known for, I don't know, I'm going to say 3 years, because we're both so young and, barely out of school. And so we have Mason Myers, who is the principal implementation consultant at Autodesk. I have to guess that he paid extra money for the extra words in his title. But we'll see. Welcome, Mason.
Hi, Mason.
Hey, Lynzie. Hey, Mercedes. Thanks for having me. And congrats on the podcast in general, as well as the Trendy Award. So you guys won an award earlier this year. That is
thank
awesome.
you.
We are award winners.
As Lynzie likes to say, we're award-winning journalists.
It's on my resume now.
Sounds like a paid title as well.
So yes. you guys go way back. I'm pretty sure further back than 3 years. So tell me, before we dive into the real agenda, tell me how you guys know each other, how you met, et cetera, and maybe what mutual friends we all have in common from those days.
Ooh.
I'll start since I'm the guest, right? So Lynzie and I went to college together at Penn State, and my first 2 years, I was a class officer for 4 of them, all 4 years, and everything was going great my first 2 years. I was class president, and then junior year is really tough, both academically, and then also junior year, one of my advisors came up to me and said, you're a pretty good student president, but that freshman class has this really good president that is just way better than you. And that is how I met Lynzie.
We started our very rocky relationship.
That's kind of how Lynzie and I met too.
Yeah. So basically, honestly, it's a good trend. I just start off with many enemies and I force you to like me.
Yeah, I think Meckley was like, Lynzie she's like selling T-shirts and all kinds of stuff. You haven't done any of that in 3 years, so.
Oh, Meckley, isn't Meckley retired now? Did I hear that?
He is. Yeah. He might be in Antarctica for all we know right now. So.
I think he just posted a video of him going down a hill in Holiday Valley. So
close. He's
still in the local area. But I'm sure next week it'll be a video from somewhere else. Yes. So we did the school thing at the same time. And then actually when I moved back to Erie, it was Mason who said, hey, I'm a part of the local SBE chapter. You should get involved. So, I think it was part of him just shirking his duties, but the other part of it is kind of what got my, my local SBE involvement started.
Oh, wow. I had no idea. I just always assumed you started all that because you were trying to beat me with SBE boards. That you
no, my spite had a different path for the beginning part. And then it was spite for you. So, it just, different trains.
So, Mason, tell us about Autodesk. What is it? Yes, that's a good starter question.
So Autodesk is a really interesting company. We are a solutions provider. We make a lot of different softwares for different industries. So architecture, construction, media and entertainment, and then obviously the manufacturing space, which is where I sit. So some of your listeners might know Autodesk from Autodesk Moldflow simulation software, which I hope we talk more about. I know a little bit about that. But there's other tools that we offer like Autodesk Inventor, Fusion 360, Vault, Nastran. All these can be used in the manufacturing space of not just plastic products, but other products as well.
Well, I think I may have some experience in the Moldflow world. Once or twice I've fired up that baby. And actually, I was going to ask you a really ridiculous question, but I didn't want to waste time on that. I'll save it for the end.
That's what we do. It's what we do.
Go for it.
I was going to, it was specifically on your don't ask me list of questions.
Okay, so we can save that for the end.
And I was going to say, if you were going to mesh a model of Ben Roethlisberger, what would you use?
Wait, so this was specifically, so for all of our listeners, before we send out an agenda to all of our guests, we first send them a primer, which is like, is there anything you specifically want to talk about? Anything interesting and exciting that you're working on that you can tell us about? And the third and most important question is anything that is off the table. So Lynzie has just
I have just driven straight into off the table because Mason is a Steelers fan, which is unfortunate for him. And as we all know, I am a Bills fan, and we are amazing. So
are you from Pittsburgh then?
I grew up about an hour north of Pittsburgh, so didn't live downtown or nothing like that, but I am from that local area. But to answer your question, Lynzie, if I was going to mesh something of Ben Roethlisberger, it'd probably be one of his Lombardi trophies because we have a lot of them. How many?
I did walk into that on my own.
You did. That should be on your list, Lynzie.
That should be on my list.
Talk about.
All right. Well, getting off a topic I don't want to talk about anymore. So, what is your role at Autodesk?
So, as you said, my paid title that you think is made up, but principal implementation consultant. That is just the terms that we use in the consultant group. I am on the consultant group in the manufacturing space, so I do focus on Moldflow. As I mentioned before, it's a really great role because consulting, we work with a lot of our larger customers that buy pretty much every piece of software. So our customers have access to every piece of software that we offer. So I might be in there working with Moldflow and other colleagues might be working with, CAM tools or Inventor or something like that. But as I mentioned, my main focus is Moldflow. So I would go in and do training, consulting around the Moldflow product line. And then when I'm not teaching or running Moldflow, I also sit on the certification team for Moldflow. So I'm helping to make sure the next generation of Moldflow associates, professionals, and experts are up to our standards.
So to clarify, you work on the actual Moldflow side and not on the Moldflow simulation side, is that right?
No, Moldflow simulation, Moldflow, I use those terms interchangeably.
Okay, gotcha. So why do you think that simulation software can be dangerous in the hands of just anyone?
I don't know if I believe that. I think that simulation is a tool, just like any tool. If it's used properly, good things can happen. If it's used improperly, bad things can happen. But I think that anyone can use simulation. I don't think that Moldflow in particular discriminates. I feel that I can teach anyone that's willing to learn. It does have its subtle nuances, I would say, but I think that's what I love about Moldflow is that I've had the opportunity to train a lot of different people from different backgrounds. And so, anywhere from an intern to someone that has a PhD, anywhere in between. And some of my best customers were like business majors, which surprised me because they were going through certification. And I was like, where did you do your engineering undergrad? And they're like, oh, I'm a business major. And that kind of surprised me because it is kind of a little bit technical to run the software. But other times I had a tooling apprentice from Switzerland who English was his third language. So anytime I'm training him, right, he has to go from English to French, French to German. And I trained this guy for a whole week. And again, just a tooling apprentice, not that that's wrong, but normally that's not the person you have running simulation. But he was amazing. He was asking questions about workflows that I've never really thought about. So I'm in the opinion that anyone can run Moldflow that's willing to put in the time.
But I think that's the key right there is the time. I know some of the just in casual conversations with you and one of our other mutual friends who does a lot of training in this arena, sometimes without that kind of training, people can kind of go off of instinct or not instinct. What kind of training do you guys offer that kind of puts people at a level where you would feel comfortable being like, okay, here you go, you can run this, you can run whatever for your company?
I think it depends on what you want to do with the tool, right? If you're just doing some very basic upfront simulations, where should the gate be? How am I going to design my runner? Those types of things can be taught in just a few days. Now, that's a few days of training, but then you have to kind of pick it up and use it yourself. Otherwise, the training's kind of for naught. But what's interesting about Autodesk is we've taken the same type of technology within Moldflow and we've actually pushed it to our Fusion platform. So someone that's maybe an upfront designer, right? They're not going to know, they're not an expert in simulation. But if those people can start making decisions about wall thickness or rib design, gate location at an upfront level, I think it frees up the analysts to do crazy in-depth simulation. So the Moldflow inside of Fusion we call injection molding simulation in Fusion 360. I don't know why we have these crazy terms, but it has a lot of built-in what we call tooltips. So if they're trying to do something, we kind of give them a little push, say, don't do that, that's not good, or keep doing that, that's good, right? But it's funny because a lot of the Moldflow experts on the team help author those little tooltips. So it's kind of like having an analyst right there with you when you're using some of those upfront tools. This was a very long-winded answer to say it varies based on the product that you're trying to learn.
So say if an industrial designer, for example, is designing a part,
right?
Would they then get an alert that, hey, this part might be tricky to create a mold for?
They could do things like if you make a wall thickness that's crazy thick, they might get a warning saying your cooling time is going to be crazy long because your wall thickness
65 hours.
Exactly. Right. So we do keep it high level at the part design. Now we are looking at incorporating more in-depth types of tools like mold design and runners, but we're not quite there yet, at least with that product.
And I will say, I don't know if you had this problem or this project, Mason, because you're so much older than me. But I think it was junior year, we had designs come from a school in Ohio. And it was the industrial design school there. And they sent you just CAD files, and they had, and the point was they specifically had no experience with moldability or anything along those lines. And you had to take that part and turn it into something moldable and functional in the actual manufacturing world, and then feed it back to them, which I feel like is kind of like the software step is what you guys are hinting at over there.
That's interesting you mentioned that, Lynzie, because I often referred that in my training because I think that was the first time that I ran a 3D mesh analysis. And I remember that day like it was yesterday. I thought it was the coolest thing ever. I thought it looked like Play-Doh flowing through a mold, which is kind of what our 3D simulation looks like. And yeah, that was a really interesting project. Shout out to Jason Williams on that one, because I learned a lot going through that project. I think it's right behind me somewhere. We can dig it out. I probably got.
Oh, mine's in the basement. I can grab mine.
Yeah, no, I got mine like right on the bookshelf.
It's just the other bookshelf in the other room. And I think about that kind of stuff all the time, because I know, Mercedes and I, well, Mercedes has more technical than like that school. Mercedes comes from things from a lot more design perspective that I don't have in any way. And like I always say, if Mercedes and I are talking, like she'll sketch something up and I will give her a bulleted list. Like that is the delineation. And I think that type of project shows where that, where people could differ so much, and having those little alerts, definitely something I feel like as one of, probably someone in the injection molding side would appreciate a designer having.
Absolutely.
But what's interesting about Moldflow is like, I'm not a very good part designer. I am not a tool designer at all. I'm pretty weak in materials, if I'm being honest. And
Tell us what you're good at.
processing really isn't that fun to me either, but I do know aspects of all four of those, which if you think about simulation, it kind of sits in the middle. So I'm not an expert of any of those, but I understand design enough to say, that's not good. Maybe we should do it this way.
Yeah. And so kind of, going along that, you have a fun little thing that you throw up on LinkedIn every Monday called Moldflow Mondays, which I love.
Love that.
Love the alliteration. So tell us, why do you do that? What kind of tips do you give? What kind of feedback do you get on that?
Right. So Moldflow Mondays, as you mentioned, is just something that I was talking with my manager earlier this year, and I said, I'm going to do this on LinkedIn, and I'm just going to see where it goes. So every Monday, I have a little post on just some random tip that has to do with Moldflow normally. And it's just this thing that's kind of spun out of control a little bit. I get a lot of great feedback. So there's a couple of us that train people in Moldflow here at Autodesk. Unfortunately, there's only 2 of us. So we have to train pretty much the entire globe as far as Autodesk customers. So I have a lot of outreach, a lot of customers. And so when I post these things, I get people from Germany and Mexico and in India commenting and having discussions on Moldflow. And it really just makes my Mondays suck less. Like it's something I look forward to. And I don't know, I look forward to posting and seeing what gets a response and what gets crickets when I make those posts.
That's great. So what did this initiative come from Autodesk, or was it your own?
I don't, I mean, no one from Autodesk really gave me the idea. I just got, I don't know. I really got tired of seeing like a lack of tech tips around Moldflow. And I think there's a lot of misconceptions around the tool, and it just kind of drove me a little crazy. So I started making a list of things I wanted to cover, and I thought, I'm going to run out of ideas here come January or June or something like that. And it just, the list keeps growing and I keep doing it. But one of our partners in Germany asked me to come speak at a conference. And I said, sure, what do you want me to talk about? They're like, why don't you talk about Moldflow Mondays? So it got me a trip over to Europe to talk about that with some of our customers.
Well-earned beer.
Exactly.
Wow.
Exactly.
So you talk about misconceptions, and I know that Moldflow can be seen as too time consuming of a first step by some. What would you say is the biggest payoff by doing the Moldflow simulation first?
Well, I mean, to people that say it's time consuming, I would say you could always go back to the hand calcs, right? If you want to do it that way.
Perfect.
Sorry, go back to the what?
The hand calculations. So you could do the equations by hand if you really wanted to do. I've done both. The simulation is less time consuming than the hand calcs. As far as the payoff, right? I feel like my professors in college did a pretty good job of teaching me what to do and what not to do. But sometimes you just have to make mistakes for yourself. And even, myself, I've made mistakes on putting gates in stupid locations. And I go back to the simulation, and the simulation was trying to tell me that I just didn't pay attention. So as far as the the payoff is really just, it's almost like having another engineer sit next to you and try to catch your mistakes. So the payoff is really time and money. I've done both, right? In my last job, I kind of was the process engineer, the part designer, the mold designer, and the Moldflow dork. And when I didn't run a Moldflow, startup was a lot more painful. But if I had the simulation ahead of time, it just seemed to go a lot easier as far as getting a process up and running.
Yeah, I know we all know shops that don't need it because the thought is too time consuming or too much expense, or we've molded something like this, something similar, it's not going to be a problem. And I think, every time you see those people stuck, it is where you go back to, would you be stuck if you had the data to kind of assist you in the beginning or kind of help you out? Because you can always do your quick cheater fixes. Okay, well, we'll just open up the gate, or we'll do, whatever. But if that's not working, now what? Like,
right.
You've already opened up your gate. You've already, prayed to the gods and they're not answering.
It reminds me of something that Mike Seppi had. So when I attended his materials seminar, he had made this reference to it was either his daughter or his granddaughter's experience. And the idea here is basically, we hold these things that we think are truths, and we go through, not even as engineers or scientists, but in life, we go through these tests of our truths, right? And so this was maybe his daughter, knowing like, okay, I turn on the TV and this specific show is on, right? And that was her truth. But then she was interrupted and she went back to turn it on, and it was like, what happened to the show, right? So it was like, she didn't know the truth of her turning on the TV at a different time and her show not being on. It's the same thing, right? It's like, you're not even taking into account, this other thing was happening that's actually affecting.
Right. It's not one-to-one. It's
right.
Many things.
And I think that goes two ways. Sorry to interrupt you, Lynzie, but to go back to the skeptics, right? I wouldn't discredit, right, historical knowledge, right? So we have a pretty diverse industry, a really good group of tooling people in our industry. Those people are not to be discredited by any means. They have a ton of experience, but I'm saying that simulation can be used in combination with those historical experiences and try to find a best path forward in the quickest time.
And speaking about those people who decide not to do any simulation up front, if they get to a point in their project where they are stuck or they are struggling, do you see a value in retroactively doing a simulation? Do you have examples of doing that in the past?
I mean, yeah, I think about 50% of my applications are existing molded parts. Now, if they're running fine, they're not going to come to me and ask me to run a Moldflow on them, right? So that's normally something is gone awry and they're trying to use simulation to fix it. I would say that a lot of times we can, sometimes we can't, right? And I try to be transparent about that. But, the upfront simulation, I really think that's a missing piece. I wish we did more of that in our industry. Mm-hmm. I was just working with a medical customer, and I love them to death. It's one of my favorite customers, but they were doing some insert overmolding, and the insert was historically metallic, and they were looking to switch it to be a plastic insert. And I was running simulation for them, and I was like, did you want to melt the insert during molding? And they're like, no, that insert can't melt. And what we found was if they used those two types of plastics, that the insert would melt. And they thought that would have cost them like 30 to 40 grand to try to fix that. So yeah, there could be times where you kind of luck into wins like that, but I think that's what you have to kind of keep your eye out for, is those kind of potential problems.
Mm-hmm. Yeah, that would be bad. Don't want to melt your insert if you are specifically trying to insert.
Sometimes you might want to have like a thin layer of remelt, but in this case, no, it was pretty severe that was not going to end well.
Great, love that. So speaking of like simulating inserts and stuff like that, like I mean, maybe that existed back in the day when I was first booting up the old DOS computer to run simulation. But is that like a newer advancement? Is that kind of stuff, part of what is really being developed by Autodesk?
So instead of answering your question, I'm going to ask you both
That
a
sounds about
question.
right.
So what year do you think Moldflow was founded? Take a guess.
Wasn't it like, I feel like I maybe know. Wasn't it like
1982.
Wasn't it like 73?
It was 1978.
I was gonna say 78.
But for a software company, that's insane. So
Yeah.
obviously Autodesk acquired Moldflow, I think 15 years ago or so. But Moldflow itself was a software company that's been around since the late 70s, which is nuts. So yeah, Lynzie, there's a ton of stuff that's been around for a long time. Insert overmolding, I think we could do that when we were learning the tool 3 years ago, as
Sorry,
to your memory.
Moldflow could do that, not me.
Well, I mean, that's something that we typically reserve for the advanced course. In our fundamentals course, we typically cover the basics, and insert overmolding, while important, is something we reserve for the advanced users, which is probably why we didn't learn about it in
We are
college.
not in the advanced category.
Yeah, it's actually pretty easy to do that. The way Moldflow handles your CAD coming in is just like meshing multiple bodies, which is pretty easy. So if you had like multiple Vince Lombardi trophies that you're trying to mesh, it would
This was all on me.
just as easy
This
as
is my
doing one.
fault.
So what are some of the newer advancements that modern Moldflow can account for?
Sure. So
That
if
are
I-
not insert molding from the early
Old
2000s.
news. Old news.
So back when I was learning the tool, I think the two things that I've been impressed with is cloud solving and meshing improvement. So cloud solving has been really game changer for us, because back in the day when I started, before Lynzie started using Moldflow, our
So many
computers
years before.
were so old and slow, and like an analysis could take hours, or several hours, if not a full day. Cloud solving has really helped with that, because now you can launch the data to the cloud and you're not tying up your laptop. So I can launch.
I do remember like having, if a group of us were doing it, we would like launch your
to Joe's machine. Yeah.
yeah, you would launch it, and then it'd be like, all right, 3 of us are gonna go down and get some food at Bruno's. What do you want? You watch our computers, so nobody comes in the lab and takes them, but like these are going to be running for a while.
Right.
That's amazing. So was it like also was this also the time of like dial-up internet where you're like waiting like I'm waiting
was actually an operator
to load?
Just after dial-up. It's actually, we weren't too far away from dial-up, like maybe 5-6 years. But yeah, Lynzie, it's basically like you're doing that now, except there's a bank of 100 computers that are crunching the job. And then the second one is meshing, right? Meshing used to take a whole day, right? 6 to 8 hours to mesh a part, which was insane. Now that's down to like minutes. If I have to clean up a mesh, right? I'm contemplating my life choices. Something has gone wrong in my project that I have to like spend time to clean up a mesh. But those two.
Same with like that. I remember starting meshes, and it was like you have to get it started before you leave the lab tonight, or you will not have it for class the next day.
Yeah.
And you're like, oh shit.
So for those of us who may not be molding experts, what is mesh? What is meshing? What are you talking about?
So say we want to simulate a part, right? My mouse right here, right? We can't just say figure out the pressure to mold that part. We have to break it up into tiny chunks that we call mesh. And these little chunks, we can calculate things like temperature, pressure, shear rate along the mass. So it's a way of taking a very complex part, breaking it into smaller subsections, do a bunch of calculations, and then we get our final answer there.
But not hand calcs.
You could, but that's what we're doing. That's what the computer's doing.
If you're a conspiracy theorist and don't want the computers to take over the world,
right,
you can do the hand calc. I would rather die.
I actually did that in my last job. My boss refused to pay for a Moldflow simulation before we got access to the tool. And he wanted me to design a mold with like 4 different materials. And I was like, I can't sign off on this design. So I did some hand calcs. It took like a whole day. And I threw this stack of papers at him and I said, this would have taken minutes in simulation, but you made me waste the whole day. But we got it soon after.
I
This
like
is
that
not
it was very sassy and it still got you the software and not fired.
Exactly.
And this is not your old boss, John Beaumont, you're talking
No,
about.
no, it was the boss in between. I've had
Okay.
so many bosses, right? How many bosses have you had in your industry, in your careers?
Oh, so many.
A
I mean,
lot.
at least, yes, more than this many. Which is
Yeah, the Lindsay's
five.
holding 5 fingers. For those of us listening, for those listening.
Those not watching the video, yes, more than 5.
Yeah, same. Yeah, I've probably had about 10.
That's crazy. I mean,
Yeah.
I'm double digits too.
Yeah, I'm probably in that ballpark. Yeah, and I think that's one of those things where, you know, it seems like a luxury, like to have Moldflow. Like if you're talking to someone who's like just starting, just trying to start building molds and get them running, you know, sometimes that can seem like we don't need this extra stuff. It's, you know, the same as like the automated dryer. Like we don't need that. We can just scoop it out. It'll be fine. Nothing will go wrong. And I think that's one of those things that gets missed. You know, as we were talking about earlier, as something that you could be spending an entire day doing work, or you could be skipping over that and then having to go back and still spend that money or still spend that day trying to pick up what you lost,
Right.
you know, in progression.
And even if when you have the tool, I like it when Moldflow disagrees with me. And it's kind of weird. I kind of have this inner monologue between myself and my Moldflow results. But I think that's the point.
It's a very interesting conversation.
But no,
for
like
sure.
you run something and you expect it to fill, like you kind of have an expectation, right? It's going to fill in X PSI or whatever. And when it disagrees with you, that's when you pause and dig in to figure out why is that different. So for me, I actually like it. I like it when Moldflow agrees with me. That means I'm doing my job. But when it disagrees with me, I think that's really interesting because that's time to pause and catch something that you might not have caught, especially if you weren't running the simulation.
So
Yeah, absolutely. It goes back to turning on the TV at a different time.
Exactly, exactly.
Redefining your truth, revamping your thesis, right?
Exactly.
So when it does disagree with you, you know, obviously you've been around Moldflow for a while, but, you know, say someone who's newer to Moldflow or, you know, just, you know, day one on the job trying to get something done, what can they do to kind of, you know, check themselves besides hand calcs? Like
I was just going to say hand calcs
Hand
again.
calcs.
just hand calcs.
So
This is a math-based program. Everybody needs a good notebook and a good calculator.
So I was actually teaching a course in Chicago, and I was kind of checking the box. Customer gave me a part. It was like not the size of a license plate, but it was a gasket or a seal. And they said that we use 6 gates. So I put the gates 3 on one side, 3 on another, symmetrically spaced. And I'm smarter than Moldflow. I ran it, and I was about to teach the course, and I was like, oh crap, I should show them the gate location tool where Moldflow helps you pick where to gate the part. And so I ran it. I knew what Moldflow was going to say because I'm smarter than Moldflow, and it gave me something that I didn't expect. The gates were basically asymmetric, and I was like, why? And so, Lynzie, if I ever have that curiosity, I run it, right? Run what Moldflow thinks I should do, and then run what I think I should do, and we'll see who's right. And that was one case where I was not right. And I love that because I was just so confident and so smart that I was going to be so much smarter than Moldflow, and it was like, no, you're not. So I guess that's the point, is like it's a sanity check. Sometimes the analyst is smarter than Moldflow, but other times they're not. So when you have that question, just run it and then back it up with data. So when I used to run Moldflow in college, like just learning the tool, I used to run like 1 or 2 studies and like my homework was done, right? The longer that I run Moldflow for a profession, all of a sudden now my studies look like they're 10 or 12 individual studies because I'm trying different materials or different gate locations. And if you launch them all, you know, you can get a lot of answers in a short amount of time, especially with cloud solving.
Well, I was gonna say, and now back in the day when you're trying to do it for homework, you only had 18 hours to
Right.
get that done. one or two studies might be all you have time for.
Right.
It, you know, you were kind of talking about like there's the gate location finder. You know, you're saying you're running a bunch of different materials. Is there like a variable or a parameter that you see from customers that they don't think is as big of a deal as it really ends up being? Like, do people just say, oh, I can just run whatever material, that's going to be fine, or oh, I can pick the gate location, that's going to be fine, or whatever else?
Yeah, so I think, yes, I see it. And it's kind of one of my sticking points is we go through training and I show them all these cool tools. And my biggest beef is when I come back to them and they're using like the default settings. Meanwhile, they should have been like, is that the melt temperature you're using? And they're like, oh, I don't know, it's just the default. So that drives me nuts because maybe you should use the default, or maybe you shouldn't. Like just put it in there, right? Figure it out. So that I would probably say the process in general. Just think about, you know, any injection molding process. If you just put in random numbers at the set point, you're going to get a part. It might be short, it might be flashed, maybe it's a good one, I don't know. But if you adjust the temperatures, the filling speeds, the VP switchover, pack and hold times, right? Things change. That's why we have all those knobs on our injection molding machine. So I would say people using the defaults drives me insane when they know that they maybe shouldn't be using those defaults.
And so say you have, like I said, someone who's somewhat new on Moldflow and they're using the default settings, and maybe someone like you steps in and tells them like, let's not.
Very politely.
Very polite. I'm sure it's the email signed with principal implementation consultant at Autodesk.
Please
Not like a per my last email.
Those are my emails. What do you suggest? Do you suggest they do more simulation to figure out where their settings should be, or do you suggest they take it to the floor and figure out there, or is it a combination?
Exactly, it could be a combination. Like, is the tool? It's almost like you have two different ways to use simulation. Is the tool in production? Because if it is, you don't need to do a lot of upfront homework to figure out gate location, runner size, right? That's known, right? The tool is built. What is the runner size? What is the fill time? Go look it up. If it's a new application, then they get a partial pass from me, because there's a lot of ways that we can use it. Yeah, we'll see. But there's a lot of different avenues you can take to help figure that out. There's even some old school code that's still available called like molding window. It's one of my favorite analysis to run because it's fast. You get an answer in seconds, but that can help you establish your mold, melt, and injection time using old school strip files that you could do by hand calcs or Excel, if that were. But that's basically what it is. It's simplifying the part into a flow length, assuming some thickness variation, but it gets you an answer very fast. I would rather you do that as a starting point than just like whatever the default is for the material.
Mm-hmm. And are you able to take different resins into account? Like, if, you know, now with everybody increasing levels of PCR, or, you know, in my world, you know, where you have 4% master batch, that's
Sure.
a different melt flow.
Yeah, so we do have a pretty large material database. We have over 12,000 materials, which sounds cool if you're a simulation analyst, but if you're a material supplier, right, that may seem on the low end. But we do have a pretty wide database, and we also have some testing facilities here in North America, Beaumont being one of them. You can pay to get your material characterized. If you are in another location, you can send it to our labs in Australia. Same equipment, both locations. They can do a full characterization. That way your material is characterized and you're going to get the best results with your material.
But can you, I guess, because you would have to make a compound of the two different materials at this point, right? You don't have a way. Is that something that you guys are working on that you can talk about, or is that not on the agenda yet for Autodesk?
I mean, you can go in and change things, but you're kind of like ripping the tag off the mattress at that point. Like, you're voiding the warranty a little bit. I don't recommend that you go in there.
Leave the tag on your mattress?
But I don't recommend, but you can. You know, we've talked to I've had conversations with other Moldflow analysts about doing something similar to that. I would like to maybe see a research project on that, but it's still in flux. But maybe I can talk to some people that do material testing and see what if that would be a viable research project.
Look at that, Mercedes. You're already making waves in Moldflow.
I think it's something that simulators have already, been thinking about for a while, but nobody knows how to tackle, right? But I just see it will start coming up more as people start to use different levels of PCR, more so than the master batch side, which is usually much lower level.
But it's kind of interesting, as you point out, you'd almost have to have different characterizations for different batches. Another thing that would be interesting is if we could put ranges on that, but boy, because we're testing for a certain batch, hopefully we have minimal amount of variation, but it's still a possibility.
Yeah, just gotta hope your end product has tolerances like through the roof.
It could be worse though, Mercedes. So my last job was thermosets. So like if you think you have, so we used to scrape the stuff off of trees in Southeast Asia. So like if you've ever had a bad day dealing with the material supplier, it could be worse.
Wow.
Dealing with gum trees.
How exciting. That's when Mason was a scientist.
Senior
scientist.
Thank you.
Such a fancy title. Again, I don't know where we're getting all these fancy titles from, but all right. Well, I think we're just about out of time here. Always a pleasure talking to you, Mason.
This is fun.
Mason Myers, thank you so much for joining us on PlastChicks.
Yeah, thank you for having me. This was a great time.
And Mercedes will buy you a beer at our next outing.
I will.
Sounds good.
I will.
All right. I will.
I will.
I will. All right. Thank you.
All right. Thanks.